Hello, my name is Ahmed Abdullah, and I'm presenting my final project for CS6460, a design for an integrated intelligent tutor. The platform that I am designing is intended to provide an AI agent as a tutoring solution in addition to an LMS platform from which the AI agent can learn. The intent is for the AI agent to learn not just from static content, which is one of the more direct and common approaches for AI learning, but to also learn conversational skills and the Socratic method, ideally through evaluation of human interactions through the integrated chat and forum features, as described by conversations between humans. The first step in designing this or considering this project was to determine what's the optimal use case, what's the optimal end goal. The objective here is to eventually have a system that is capable of learning how to coach a professional or a struggling student using the Socratic method without necessarily having to have a significant amount of guidance, or at least to augment a coaching relationship for a struggling student or a professional. The first step in this design was to evaluate existing learning management systems, LMS, and intelligent tutoring systems, ITS. These platforms exist and have been around for a number of years, and many of them offer different features, functionalities, available technologies, and the first step that I took was to evaluate what was already available. Ideally, I don't want to recreate the wheel, so I tried to figure out if there was an available solution or an available platform that could be readily modified to either add AI functionality to an existing LMS or to perhaps add an LMS functionality to an existing AI tutor. Unfortunately, the existing systems that I had available and could review weren't in a position to readily be adapted to the use case and the solution set that I envisioned. Specifically, New Tutor is very static in content and focused on individual subjects, and the available open source LMS platforms such as Moodle are extremely complex and require a lot of manipulation in order to add a new AI agent to them. The conclusion of this initial research was to design a new platform, unfortunately. Based off of the research that I did, I evaluated what types of students, what types of roles are necessary within the platforms, and what type of features would best serve the AI agent and the students who use the platform. Firstly, of course, were the human user interactions from which the AI agent is intended to learn conversation. This would be a chat function as well as a forum. In addition to that, and very common features that are necessary and will help the AI agent learn from static content, is a knowledge base with existing questions and answers, as well as available resources that the agent can access and evaluate, as well as calendar entries and other news entries that may be posted by the instructor. This set of roles, in turn, has individual sets of use cases and responsibilities and available actions that each role can perform, which is outlined here in the use case definitions integrated in the page currently being displayed. Once these use cases were defined, the next step was to design the components within the LMS platform that would support the features and the roles and responsibilities and available access defined in the use cases. This LMS uses a very simple MVC, Model View Controller design pattern, the API gateway at the end to the left, is the view, which interacts with the AI agent API client, as well as any graphical user interface, which in turn communicate with the gateway. And the gateway is responsible for forwarding requests appropriately to the controllers that are being requested. With the exception of the admin, user, and registration controllers, most of these other features are handled by feature-specific controllers and models. For example, any interaction with the forums, whether it's posting a new thread or creating a new post, would be handled by the forum controller, which in turn operates with the forum model to store any changes or store that data to the database or subsequently retrieve them at a later date. These models, as presented here, are very simplified. It is possible and may be required during implementation to segment them to additional models based off of how strict the object relational model is selected during implementation. And that's going to be language specific, which from a design standpoint, I opted to leave generic and give some flexibility to the developers in the future. The second component diagram that drives this solution is the heart of the AI component, which is the natural language process controller and machine learning controller, which in turn interacts with ensembles of different algorithms from a machine learning standpoint and different data models based off of the type of interactions that the language processor is evaluating. Class context model is responsible for evaluating the flow of an entire class and is expected to be evaluated at the same time as all of the other models. The conversation model and the conversation pattern model are both data that's analyzed from the forums and chat models. Basically, these two data groups are designed to correlate human conversation with data that the AI can understand and process to evaluate for responses and tone of response. So in this context, the conversation model is responsible for evaluation of the content of a conversation, and the conversation pattern model is responsible for evaluating the tone and emotional context of that conversation. Finally, and potentially most importantly, is the knowledge model. This is responsible for evaluating any static content, any resource that the instructor posts, any calendar entries, any news entries, since this does not depend on human interaction, synchronous or asynchronous human interaction, and is set. This data set is intended to or expected to be the highest probability of accuracy in response data. The way that this AI agent works is as the course is running, while the agent is learning, initially without response, and as it gathers updates and gathers more data, the language process controller is responsible for evaluating the language of any and all interactions and available data, as well as the tone for human interactions, and stores that into these 4 different data sets for each instance of the AI. Once the AI is allowed or has a sufficiently high confidence level in responses to start proposing responses to students, this data is in turn queried. So first the language processor processes it, sends the process data to the machine learning controller, which in turn trains all of the different machine learning algorithms. That's step 1. Once the response needs to be generated, the language processor processes the response and forwards the query to the machine learning controller and says, machine learning controller, this is a new conversation. It requires a response. This is something that it's not a previous conversation. It's something that needs to be evaluated for, what response needs to be, or no response as the case may be. The first step in that is to send the new conversation or the new message through the classification ensemble. The classification ensemble is required for evaluating the new conversation for context clues to figure out what the potential subject matter is, what the potential keywords may be, etc., to classify the type of incoming request. Is this a question? Is this a statement? And how might that apply in the historical context of existing conversations? Once that context has been determined by the classification ensemble, the machine learning controller takes that classification and runs it against the clustering ensemble. The clustering ensemble is a set of algorithms that are responsible for finding the most likely similar case previously and responding with the content of that previous case. So in the event that a student asks the exact same question, then the conversation model and the knowledge model are queried to determine what the most likely data is, what information needs to be conveyed. And then separately, the conversation pattern model evaluates the emotional tone or the general context and tone of the message to determine the appropriate tone of the response needs to be. So both of those are handed in turn to the language process controller, which is responsible for synthesizing the response using the information based off of the conversation model and knowledge model from the cluster, and then also using, formatting that in the tone and in the syntax that's dictated by the conversation pattern model. Separately, as an aside for the UI, the design includes some wireframes so future developers can understand how a UI may or may not look. In this case, a very simple example, a tutor is logged in. They can see the courses that they're assigned to for this particular class. Here's the course syllabus, and here on the left side are the menu options that are available to them as a tutor. That's expected to change and is intended to be flexible with regard to implementation, but the UI design was intended to provide some visual clue as to how the system may look and operate. Separately, on the back end, on the data side of things, I have included an ER diagram, the database diagram, which defines all of the different tables and types of data that need to be stored for each of the different components. For example, users need to have an email and password and have an admin flag as to whether they can make administrative changes or not. Separately, new users are assigned to classes or may register for classes, and when they register for classes, they're set with a specific user type. And this database design overall for the feature sets outlined in the use cases and the available models and information that needed from the components. This is a robust database design and includes features such as multiple knowledge base entries. It has potential for multiple chat sessions per course. It's not just you only have one ongoing chat. And it has the ability to create and submit quizzes and multiple submissions based off of the type of answers, etc. And finally, the last component of the design is the AI specification, which in turn takes into account or integrates all of the other components or all of the other aspects of the design into one final piece. This API specification is written in OpenAPI 3.0. Originally it was written in 2 and later upgraded. And it provides the paths for all of the different use cases that were outlined originally. So if an admin needs to create a new user, then that admin posts a user. If the admin needs to modify a user, then it puts the new user information to the same to admin user with that specific username or ID, deletion, etc. So all of the different API commands should align with the use cases. And in addition, where you see these references, the individual components are also indicated and align with the database design. So the same object created by an admin in the UI would in turn be forwarded to the calendar controller in this case. The calendar controller would send this object to, would perform whatever action is necessary to validate, would send this object to the calendar model, which would in turn store it in the database for creates or update it in the event that an API put is received, etc. One of the benefits of using this API specification is that it generates documentation and provides examples of how the API can be called. So for example, if an administrative user wants to create a new class, then that an admin function is actually performed by posting a JSON request, in this case, with a new class object with these parameters and sending it to this URI, which is responsible in turn for, saying or expected to say this is a successful operation in the end. So overall, my hope is that this is a very straightforward application. I look forward to hearing from a future student or group of students who are interested in implementing. And who knows, maybe I might have the opportunity to play with it a little bit myself as well. But thank you very much for your time. I look forward to hearing from you, and I hope you enjoy the presentation and enjoy looking through the artifacts generated and the report written for this project. Thank you and have a nice day.